In chapter 1.1, we are looking at how to solve equations. And so first we need to understand what equations are. Equations are basically statements of equivalence. So if I say something like 1 plus 10 is equal to 11, well, that's a true statement, right? Because 1 plus 10 in fact combined to be 11, and it's true that 11 equals 11. So that one checks out. This is a valid statement of equality because the statement is true. Let's compare that to a statement like 3 minus 9 is equal to 11 minus 5. Well, 3 minus 9 gives me a negative 6. And 11 minus 5, well, that gives me a positive 6. And we know from how integers work that negative numbers are not equivalent to positive numbers, so this statement is not true. This is a false statement. And so this statement of equivalence is wrong. It can never be true. Let's look at a slightly different statement that involves our friend x. So if I say that x plus 3 is equal to 11, now I need to start using my algebra in order to solve for a value, to understand what x means. And so this is an example of a one-step equation, right? I only need one step because all I have to do is subtract 3 from both sides. I have to do the opposite function. Whatever is happening to the x here, I do the opposite. And the opposite of adding 3 is subtracting 3. And what happens is those cancel. And I'm left with x is equal to 11 minus 3, which is 8. No big deal. That's a one-step equation with addition. What if we had a one-step equation, say, with multiplication? Something like 6 times x is equal to 24. Well, like over here with addition, all we did was did the opposite function, which was subtract the 3. Here we'll do the opposite function of what's happening to the x. That says 6 times x, so the opposite of times is divide. And from a previous video, you should remember that whenever I perform a function on one side of the equation, I have to do it on the other. Now, this is a factor of 1, so we can get rid of that 1 because I have only one x. 24 divides by 6 4 times. Both of these are examples of how to do a one-step equation. What if I were to add both of those steps into my equation? What if I had something along the lines of 3 times x plus 7 is equal to 28, we'll say. 3 times x plus 7 is equal to 28. So now we want to understand what x is. And here we are multiplying x by 3, and then we're adding 7. So the way to unpackage that is to do the opposite functions, and we have to do them in the opposite order that they occur. See, this is 3 times x and then add 7, so the first thing we want to do is subtract the 7. Okay, those cancel with 0. 3x is now equal to 21, and now this says 3 times x, and what do we do with that? The opposite function that is to divide by 3. And so x is equal to 21 divided by 3 is 7. And the final thing we do is we check it to make sure it's true. Is it true that 3 times 7 plus 7 is equal to 28? Well, 3 times 7 is 21 plus 7. And that in fact does equal 28.